remember that it's not a torch. You actually have to speak into it. So if I start drifting, just kind of do a motion. Like, it's not a torch, Tim. Come on. I'm going to do an experiment here. And that's why they call him Grimace. Every so often it works, and everybody gets quiet in the room because they're like, yeah, why do they call him Grimace? What a weird thing. Okay, so I have 30 minutes to talk, I believe. 25 minutes, so I lost 5 minutes already, and I'm cracking jokes. So today we're going to talk about beyond DevOps. What does that mean? Well, it's Kubernetes and the platform engineering era. How many people have heard of platform engineers? Okay, we're going to come out with a new certification on that soon. Is everybody going to take that? Okay, good. Well, if not, I'll hopefully convince you that it's a good idea. Okay, so let's jump right in. What are we talking about? This is like a quick agenda of the talk that we're going to cover here. So what is platform engineering as distinct or similar to DevOps? And then some of the future. This is where the future proofing is coming in. Now, as we're talking about Kubernetes, people say, well, what's going next? What should I study? What should I learn next? And the honest answer is, I really don't know. Okay? This is the joy of a community-led project, because it's not people like me telling you what to learn. It's you, the community, that are using stuff, saying, you know what we really need? We need a tool that does this thing. And that thing can either be great or not so great. And there might be 5 of them. And at the Linux Foundation, we don't choose winners. We listen to you. So I come to events like this, and people find me at the booth, and they say, why aren't you doing this thing? I don't know. Let me go look into it. And this is what me and my team do, is we listen to you, the community, then we help the community work with stuff, and then eventually I write a course on it. So we're going to talk about serverless AI/ML. Some of you probably have heard of AI. It's kind of a big thing, evidently. That's what I heard. We'll talk about edge computing and how that's made its way into Kubernetes, WASM, and some of the other things going on. So DevOps, or DevSecOps, as it's called. Or what I like to talk about is DevSecOps Plus, because then everybody leans in, they're like, what's the plus? I have no idea what this is. So DevOps is where we say you have to do everything. That's the secret behind it. So grab a broom, you're going to sweep up later, you're going to write some code, you're going to do operations stuff, and then turn the lights out when you leave. So this is a lack of silos. Okay? And I love food, as you may be able to tell. So I'm going to use food references. We see a very fancy photo made by AI. So all the 15 fingers that the one guy has, that's on purpose. But this is an example of a kitchen. Okay? So you get a restaurant, and now I have short order cooks, and they're all doing stuff. One guy can be on the fry team, and then he can be cutting vegetables, and he can be working the grill. You can do everything in that kitchen, depending on what the needs are right then. But you all have a specialization. You get known for the fry station. You get known for the burger station, whatever that is. This is a typical DevOps team. We all do something. I tend to do this one thing, but I'm going to write code if I need to, and then I have to support that code in the operations side, so I'm going to write better code, and back and forth is what we do. We do stuff like setting up CI/CD pipelines. We work on things like getting rid of the silos. Again, I have to do every job that's here. All of these things are part of a typical DevOps team. And this has been good. I think that's the speaker that's causing me problems. So this has been a good thing in many ways because we have a scalable environment. It's very agile, which is what cloud is all about. That I'm not stuck with a legacy system. I can change it tomorrow. So if the fish special is really good, I'll have more people pushing that out. On the other hand, if tomorrow is steak, great, we're doing steak tomorrow. And if it's big steak, small steak, whatever the cut is, my team is able to keep up with it. Now, and this is where the cloud was very handy, because it's a disruptor. We're saying, we'll do whatever you want. It's not a legacy app. It is a microservice. It's transient. It's distributed. Do what you need, scale it up, down, and this team will help you get it done. Well, now we've come full circle back to platform engineering. So now I'm saying, well, I want to actually do it all robotic. And I now want to have pancakes that made perfectly every time. You can bring your pancake mix, and we can do, walnut surprise, we can do butter pancakes, but they got to be pancakes, and they got to go through my system. So we have now come full circle back to the legacy app, and we set it up one way, and you can make any choice you want as long as it uses this one robot. And that's effectively what platform engineering is. is that we're taking a lot of that agility out of it, we're taking the choice out of it, we're automating, we're making it a very, very persistent way of doing something, sort of like setting up robots. Now, in reality, we're probably going to have like, you go to McDonald's and they have the fry machine. They hit a button, well, it depends on McDonald's, but it's an automated process. It gets dumped, 3 minutes later it's taken out, the robot's doing it. Well, that is a good example of where I'm cooking food, I'm doing one thing, it's repetitive, I need it to be durable, done right every time. This is a great place for platform engineering. So, yes, it's still working with Kubernetes. It's kind of going backwards into a very particular, not changing environment. And it's going to be the push and pull. So some shops are going to see a lot of development. Some shops are going to see a lot more platform engineering. And all those people that hated the agility of change every 4 minutes with the previous DevOps way of doing it, and microservices, and writing 4 lines, and pushing it into production, they're going, oh, thank God. Now we're back to the way we did it. Now, this isn't necessarily a bad thing. So again, kitchen references are one thing. Cars, we live in Austin, there's scooters everywhere. So legacy apps were like city buses. You have to live on the bus route, it does one thing, it does it really well, and it's big, and it runs that route. Well, guess what platform engineering is? It does one thing, it does it really well, and you have to fit that machine. So we're going back to that legacy app, and the whole reason that we went to scooters is it's where am I? And when I leave the building, I want to hop on my scooter and go to my apartment. I don't want to take the bus. And then when it's raining, I jump in a different microservice, an Uber. And when I want to get the fridge from a Home Depot, there's a different microservice, that truck. And then when I move cross country, because the heat got to me, it's a microservice. Right? So this is the balance. Kubernetes and the cloud was about microservices. That scooter, the Uber, the Home Depot truck, and all that. And here we are back to, it'd be really nice? A city bus. If only I had a bus that did one thing really well, as long as you live on the bus route. So it's not a bad thing, but this is the nature, I guess it's the ultimate extension of a flexible cloud in that it does what I want really well. And it's changeable, probably more than the typical legacy app, but it still is almost a contraindication that the maturity of my environment is getting to a point where we want something that is durable because we're not changing anymore. We're not a startup anymore. Now, we want to scale this to a massive level, and if you're rewriting code and I have 15 different versions and my traffic is being split, and I don't even know who you're talking to anymore, that might not be durable in a scaled environment where I went from 500 customers to 10,000 customers. So I'm not saying it doesn't have its place, but I'd like to point out the irony that we've come full circle back to legacy app thoughts and approaches. So serverless. Serverless is pretty cool because you don't have to do anything. You just bring your code, right? That's kind of nice. So why do we need Kubernetes at all if we have serverless? Why would I even have a container? I just want my code to run. And that's true. And there's a reason that serverless has not taken over everything. And there was people who were like, Tim, don't even learn Kubernetes anymore. Just start writing serverless. I was like, oh, that sounds awesome. Just my code runs? Wonderful. Well, what are the downsides here? Well, let's talk about upsides. We saw Knative and OpenFOSS. Those are some different projects to look at as you get more into it. But it's just the code. You only pay for the code. You're not keeping traffic container. It's just the function that you want to run as many times as you want, and you only pay for that time. But some of the downsides is cold starts. How long does it take your function to be ready? So now, I have a pool of these running. How big is that pool? Now I have 15 data centers. Well, now I have a pool of 15 and 15 different data centers, and who's managing it? And when are they ready? And so now I'm paying as back to being a container, something that's running. Then I have debug issues. It never runs local. Doesn't run a container. It's inherently in your environment. So when I have this running in one zone from Amazon, I have to know everything about that environment because I can't test it local. It's not running local. I'm testing in a different environment. It's sort of like, hey, how does this food taste? Well, I made a similar recipe in a different restaurant, and it tasted good over there. Well, that's great, but that you can't debug my recipe with me anymore because it's entirely different. Like I go to Mom's house and the lasagna is amazing. How come my lasagna at home isn't good? Well, different ingredients maybe. We don't know. And this is where serverless is. You have to do your development in that environment, and if there's any change, it may not run the same way. So debugging becomes quite a complication. Cost. Well, it turns out that when you actually add up all those pools and all the debug time and all this running, is it a huge savings? Depends on your app. It really depends on the app. So like every other choice, it's not a clear cut, this is always the best way of doing it. A lot of management types, those people, I can say that now I'm in management, you can make fun of it when you're there. But we're like, don't tell me anything. I don't learn anything. What's the silver bullet? Like if I can remember one thing tomorrow, teach me what that is. And this is where this comes in is it's not always cheaper. And then the head explodes. Well, now I have to think. And I didn't get into management for thinking, so it's too much to handle. Back to containerization, it's durable, dependable, I understand it, it's well regulated, it's gonna run the same way, that's the whole point of containers. So yes, there are some applications that this is gonna be the best thing ever, and I think it's gonna grow, and it's gonna keep growing in the Kubernetes environment, especially, again, platform engineering. What's that about? Durability, reproducibility. Those environments are gonna lend themselves to serverless then. I found that niche, and since everything leading up to it is always the same, okay, now it makes more sense. I can debug it and go through the hassle once, but it's gonna keep running. It's gonna keep doing these things over and over and over again, whereas in a typical DevOps environment, that doesn't make sense, because we're changing everything all the time. The underlying container, I was using Alpine 1.32, tomorrow's 1.33. What else changed? Well, I don't know, with this one library. What could that matter? Well, it can matter quite a bit. So this is gonna be an area that will grow, but there's a reason it hasn't taken over yet. But I would keep an eye on some of those serverless projects, especially as you move towards a more consistent platform engineering environment. AI, we've all heard about AI before, maybe. So there's a lot of things that go into AI, and Kubeflow, Kserve, Tecton, you guys can read. I won't read this to you. But these are all different tools and ideas that you can use in your environment. And I wrote out someplace that I was doing it this morning, like, what are all the kitchen references? Because that's the important stuff. What's the kitchen reference, Tim? So Kubernetes is your kitchen manager. Kubeflow, then, that kind of handles everything. That's your head chef kitchen manager. That's the guy making it happen. Kubeflow and Kserve are very similar in that sense. Then we have the waitstaff, Kserve. They're bringing the food out to the various people. We have the Tecton, and those are your prep cooks. They're chopping it up. They're making sure all the potatoes are chopped exactly the same size. They're automating that repetitive task to make sure it just gets done over and over and over again, which as you're training and retraining in libraries, you end up doing the same sort of tasks over and over again. You want it to be consistent so you know what you're changing. I mean, how many people know that if you ask AI the same question twice in a row, you get a different answer? Right? So we want to minimize that because we want the right answer every time. I love the word hallucination. I'm going to lie to you completely and just make something up. But that sounds bad when I say it that way, so I'm going to call it a hallucination instead. So I tried it at home. It didn't work. No, you're hallucinating. I really was home this whole time. I wasn't at the bar. Honest. It doesn't work. Just, note to self. The Argo is your sous chef. So that's kind of not quite the head chef, but it's helping you coordinate that workflow. This is going to be an important part of that. Argo's become very popular. If you aren't using it in your pipeline, I would encourage a good look at it. It's really grown. Jenkins has kind of drifted off. Some of the other tools have drifted off. There's no one answer, but if you haven't chosen, Argo is a really good one to look at. Kata, that's your smart oven. So that's the new inference request. That's where I have my training data, and then the question comes in, and now I have to kind of guess, using that data, what is the question, and then what's the answer. And that's an inference process. So that helps with the inference. Volcano is your industrial mixer, and that's batches of dough and so forth. That's your distributed training. This is where I'm going through. So you put 500 pounds of flour in, you put your water in, this is the mixer that's bringing it in. That's part of that AI ML workflow. And then the cloud events, that's as the events come in, as the data arrives, that's your order system. So the little toast handheld thing that somebody's punching in the order, that's effectively the tool in the cloud that is saying, data has come in, we need to then kick off the rest of this. So these are the main parts of AI tools, and AI is growing, it's not going anywhere. Okay? So what would I learn to future-proof my Kubernetes knowledge? These are the projects that I would look at in more depth. Some of which we have training on already, some of which we don't. As they grow, we'll probably build more. And we'll talk about how do I keep up with that stuff. Edge. Edge is a huge topic that is quite popular in many ways. And what does it mean? Well, in this case, it's a food truck. Okay, so that's the kitchen reference, is the food truck. I know, it's pretty lame, but this is my job. So the Cube Edge is a good one, but this is where we are trying to interact with sensors and so forth. This is an area that I think we're all going to see an awful lot of growth. In general, the cost of various tooling is coming down. So AI and Kubernetes, you're going to see interacting with that edge even more. So the light switch, your watch, your room sensor, HVAC, the robot that's going to take the groceries into your house, that needs to have local knowledge. It can't be relying on a network connection to some master machine to come back and tell it to keep walking. So we're going to have these helpful devices, drone delivery devices. All of these things are going to be having a connection with some local decision. So I want to deliver a pizza to the right place. Well, the cloud is going to say, deliver a pizza, this is the pizza, and this is the address to go to. So it's going back and forth. That edge device has to be autonomous to some extent. So this is what we're talking about here, where we're unifying the connection and the control of those edge devices. So I could use kubectl, kubectl, it's whole flame, or what is it called? But a kubectl command, I can manage all of it. So I and my team no longer have to have 5 different types of command and control to get this to work. It's an integration into the environment, which is my Kubernetes environment. So same command, same pipeline, same control, but now I'm dealing with these autonomous devices with very little hassle involved. It also allows me to scale very well. So whether I have 5 drones or 500 drones, I'm able to scale. Just part of the reason we use Kubernetes, it's so easy to add to that size. FinOps. Well, the good news is money is never an object. So we could probably just skip this slide. Nobody has those constraints in their environment. How much are we spending? And my check to Amazon was how much? Holy cow. And of course, it's because you're using it. It's not just giving it away. But keeping track of this is a big part of it. There's tools like KubeCost, which are common. There's a lot of we have an organization called FinOps. It's a Linux Foundation project dedicated to this, to how do I manage the costs of my environment? How do I know what it is? And there's a lot of effort right now to make sure that all of the various cloud providers and teams report their information the exact same way. So now you can make an apple-to-apple comparison. Because right now, I might call it something, and then mine and AWS and GCE and DigitalOcean, they all say something slightly different. They're counting a different value. Now I really can't make a good decision. So FinOps and FinOS and some of these different projects we have are trying to make that, let's do a standard. Like, what is a CPU? Let's define it. That's what a CPU is. What's memory? That's going to define and so forth. So that will give you visibility, and then you can make decisions from visibility. So this is an area that now that we're deploying a lot, whole businesses are being run in this environment. You're going to see more and more of these opportunities. I would keep track of that project and the FinOps project in general, and FinOps project in general, because both of those are really becoming more and more important as the cost of our cloud, cloud providers, not on-prem, but outside providers, is showing up as an important factor in our particular environment. WASM. WASM is another area that I would definitely look at. We have a course in it about how do I make games using WASM. Because we all know, as tech people, that games are the best stress tester. That's why when I'm at work and I'm playing games, I'm actually stress testing my environment. It might look like recreation, but in reality, Doom 7 is really about testing my box. That's really what it's about. So that's what we're talking about here is WASM. Now, WASM has started off in a very fractured environment. Everybody had their own version. There was no common debugger. Its idea was the same, but I couldn't take code from one area to put to another. That is really slowly starting to filter out. So WASM the concept here is frozen food. So you cook it. I'm going to make it in my facility, and I'm going to send it to you, and you're going to cook it. That's what WASM basically is. I'm sending code for your browser and your system to run instead of mine. So now the speed to which things happen, so in a video game, that's why it's so common, is you find an object. You just have to tell me you find an object. I want to paint the entire screen for you every time. Your character moves, whatever it is. Just tell me you picked up sword number 7. Cool, done. It's now owned by this person. It's no longer going to show up in that place. So you minimize the latency going between it. More decisions are happening local. It also means there's less CPU, less cooling, less money for me. So if I use WASM in my environment, your experience is better and my cost is lower. How handy is that? And I would only suggest you even getting into it now because these organizations have come back together to where we have a common debugger. So you can do that together to understand it, so the code can go to the different environments, and when it doesn't work, you can say, at least I know why. So WASM is definitely a growing area, and we have some training on that. So I have a couple of minutes left. How do I prepare for the future? Well, as it turns out, I would suggest more CNCF courses and more Linux training. I know, shocker. So the official Kubernetes documentation. Now, at first, it had some bad rap, but it has gotten really good. So it is worth using. So if you drifted away, come back to us. We've gotten it to be quite good, updated, and useful. Definitely good. The CNCF training courses, events like this. Events like this are very handy for keeping up with stuff. KubeCon, if you don't go to anything else, I'd go to KubeCon. Future-proofing, this is a question we often get. Cloud-native practices, again, which you can learn from the above. Managed services, you're paying somebody else to do it. So you're like, Amazon, I'm paying you this money, so you do it. Now, I'm an on-prem fan, but you can do that. And then LF education, there's Thrive Enterprise. So this is something I'll just talk about real quick. Not only do we have courses, we are doing micro-learning that we're constantly updating. So now, every time something changes, we're putting out a 10-minute video, a 20-minute tutorial in small little chunks, and it's an all-you-can-eat buffet. So you pay a price, your whole company can sign up for it, and you say, just go there, and it's curated. So you're still going to keep your other stuff, your Udemys, your Coursera's, and so forth, which are generic and not that updated. Me and my team, what we do is we're constantly paying attention to this. We update it all the time, up the time. So we'll be updating some stuff, like some courses we update every week, because the technology changed. So you could spend your day on AI going, I hope this one knows, and it might hallucinate, or there's a bunch of humans involved, and we sit down, and then if they don't do it right, then I yell at people, it has to work, and then we push out a course, and so forth. So people often ask me, how do I keep up with all these 50, 60, 70, now we're up to how many projects, constantly changing, when I just want to do my job? This kind of service, which is what we sell, is a way of doing it. It's curated, updated, technical content. And it's additive. It's not everything you'll need, but keep your Udemy, Coursera, and so forth. Put that layer on top, so you're getting that curated education. And then people like me come here, and then you can come find me and say, you know what I need? I really need this topic to be covered. Like, okay. I go back and I do it. So we also have a feedback loop with this community. We want to serve you. Okay? So that's a real quick run through. We have time for like one question, sadly. And before I forget, there's also a discount code. So if you didn't know about this, 40% off. Take advantage of that. Take a photo of that one. KCDA, this is good till May 23rd. And now we have time for one question. What's that one question going to be? Anybody? Okay, well, I dodged questions this time. That's awesome. Thank you so much.